So for our first example of a full sectional drawing, we're going to create a feed block. And as always, I would encourage you to use this video as you're working inside the AutoCAD web app and sort of follow what I'm doing to give you some practice. You're going to need it for the assignments and other practice assignments that you do. So we're gonna look at this feed block. You've seen it before. I used it for the example of what a countersink and a counterbore are. And our goal is going to be create a full sectional. So we're going to run our imaginary bandsaw right through the middle of this thing. And I've got it started because you should have lots of practice with your orthographic views by now. So I just took care of the top view of this. I didn't think you needed me to show you how to do that part. One thing I did want to bring to your attention though is, again, pay attention to the rounds and the fillets. Essentially the same thing. Anytime you see this little scattered line on a pictorial version of an object, it indicates that's a rounded section. Anytime you see a hard, sharp corner, it means there's no round. So if I look at this object, and I'm representing it in either an orthographic view or section view or something like that, I want to make sure that in the appropriate view that I have my fillets on and to the right, the correct radius. So when I look at the top view of this one, okay, the only fillets that I can see from the top view are going to be the ones in the back corner. So if I look at the back corner of this object, you can see that it's rounded right there as it kind of goes around the corner. Okay, but there's nothing else I can see on the top view that is going to be a fillet. I'm going to have more on the front or the section view. I just wanted to make sure that you understood that that is a fillet because it looks like it should be on the drawing, and these are not filleted or rounded because in the drawing it looks like they're very sharp corners and you don't have that scattered line. So that's why I've got that round there. I've completed the top view as with all of the dimensions I have, but I'm still missing some. I'm still missing an outer circle here, and I'm still missing the bottom of the ramp. So I don't have this line yet, and I don't have this outer circle. And the reason for that is I can't tell where those lines are supposed to go from the information I have in the drawing on the top view. I'm going to have to create my sectioned view and then trace some of those lines up. So I need to finish off that top version after I've drawn the section view. So let's get to it. Section view is going to go down here. It's going to basically be the front view of the object, except it's going to be cut in half to give us a better idea. You can tell for this object, I could represent the front of this object, but it's going to be, there's not going to be much there. It's going to be blank. It's just going to be solid metal from this side to the other side unless I cut it in half and give a better idea of the internal details. So this is an example of why we would use a section drawing. It gives us a better understanding of what's going on inside the object. Now most of the lines that I've got on my top view can still be used on my front view, and that's by design. I'm going to throw a couple more con lines in there to help me. And maybe I'm going to pick yellow for anything that's a bore or a hole. So I'll do something like that. And then we'll just copy this line over. CO space. And I'm going to copy it everywhere I need it. I need it there. I need it there. I need it there. And so on. I need to know where the edges of all of these holes are. And then I might make the center lines of the bore and the countersink. I might change those, go to properties. I'm going to change those to a different layer. I'm going to make those the center layer, which I believe is green. All right, so let's start drawing this thing from the side. You start out just as if it was a regular front view, right? We need to know how high this is. And it looks like it is kind of hidden in the object here, 25. And I noticed that there is a dimension missing. Our height for this particular section is not on the drawing. I'll have to add that before you see this textbook. But it is 45. I think I accidentally deleted it right there. So this larger section here, or this taller section, is a height of 45. So let's use that information to move forward with our front view, which we're going to turn into a section view. I'm just going to go straight into my line tool. This is the ground. This is the end of the object, so I know that it goes all the way from one end to the other on the ground. That's great, and I know that this is 45 tall, so I'll go up there. And I don't know how far to go across, or do I? Let me check. I think I do actually. 48. So at the start of the ramp is 48. That's great. So I'll go over 48. And that's where I'm going to stop for now, because I know this is a 60-degree angle, but I'm not sure where it hits the bottom. So I'm just actually going to draw this line maybe a bit too far for now, and then we'll trim it later. Now I know this is 25 in height, and it'll go over to where it meets the angled portion. Which means I just have to, I can either trim this or I can drag it back. Dragging it back is a little bit more dangerous because you can accidentally change the angle, but if you're careful, it's generally not a problem. Okay, so there's the rough outline of the front view. While I'm here and while I'm thinking of it, let's handle the fillets. So the fillets are the areas that kind of look spray painted, little kind of dotted. And what can we see from the front view that is going to be filleted or rounded at R2? We're going to see that portion. We're going to see a little round there, and we're going to see a round there, and then we're going to see a round at the end. So we're going to see more fillets on the section view than we would have on the top view. Before I put these fillets in, I'm going to drag this line up to the top view, just to note where the exact middle of that fillet would have been, because you will still see a line up here. Even though it's filleted, it's going to you're still going to have an indication that this is higher than this section right there. So I'm going to put that line in before I fillet it. It wouldn't necessarily be wrong to do it after. You just have to make sure you hit the middle of the fillet. Okay, so now I have that line up there, which I did not have before, and now we can fillet. I'm going to go to my fillet tool, which is in Modify, Fillet. Hit R to specify a radius. My radius is 2. It already was 2, but that's fine. I need to fillet this line to that line. Hit spacebar because I'm repeating it with the same radius. This one to that one, and then this one to that one, and I believe the very front one as well. So that would be this guy to that guy. So that should take care of all my fillets. Can't see the line right now because the red's hiding it, but if I delete the red, what reds do I have? Oh, it's locked. That's fine. Now you can see where those fillets are. Not sure if I'll need those two end lines again, but we'll see. All right, so I got my fillets, and I've got that up there. I think we're ready for us to start building these features and then cross-hatching. So let's start with the counterbores. They tend to be the easiest. I have this center of this circle. I have the center of that circle. I have the outsides, and that's all been traced down. So that's work I don't have to do. What I do need to do is know how far down to make the heads, and the heads go down 10. So the length of the head section there is, or sorry, the depth of the head section is 10. And because we don't have a second depth, we know that it goes right to the bottom of the object. So I go right to my object line tool, and this is the very outside. I know it goes down 10. I know it goes all the way across to the far side, and then I know it goes up to the top again. So I just took the outside lines, and now I need to move to the inside lines. Still line tool, this inside line goes right to the bottom of the object, as does the one on the other side of the center. And that's an easy counterbore. So by creating the top version first, I didn't have to do any measurements and offsetting down here. I just needed to drag the lines down, and it was perfect right away. I'm going to just hide all my con lines right now. I'm going to take this, and I need to move or make a copy of this to take care of this one. Now, I could do the same thing. I could trace everything down, but I know exactly how far apart the centers are for these. They are 30 apart. So if I copy this object, so if I CO, the one I've drawn, from the middle of it, anywhere in the middle, it could be the middle here, or it could be the middle on the top side. I'll take the middle here, and then I'm going to make sure that it snaps to a 0-degree angle, and I can actually make the copy a certain distance away. So I know this distance from the center to the center should be 30, so I'm going to make that 30, and it puts it in perfectly in exactly the right spot. And we can tell that by just looking at either the center line or looking at these lines. It lines up perfectly. So just save yourself time wherever you can. This one's going to be a little bit more difficult because it is a countersink. And for a countersink, we need to do that angled approach. We have the inner bore, and we know that the inner bore goes all the way to the bottom. I can just draw that in right now, and then I'll trim later if I need to, and I will need to. I'll just draw that in. That's the narrowest part of this object. For the countersink, and we have done this before, our depth for the entire thing is 30, and our countersink depth is 7. So I was kind of lying actually when I said this went all the way down to the bottom of the object. It doesn't, it only goes down 30. We have 2 depth measurements for the countersink. We only had 1 for the counterbore. So I need to go down 30 from here. And then I can go across and then back up. So that's as far down as this one's going to go. The second depth that I have, 7, is where this part starts angling up to the top. So I do need some sort of construction line that goes down 7. And I'll just use red. Looks like I haven't used a whole lot of red yet, so we'll go down 7. And then I'll go across, and then up. And then the last part, because we now understand how to build a countersink at a certain angle. We did all the math before. You know what it is. Now you just need to use that same math every time you see an 82-degree countersink. If you see a different angle of countersink, you're going to have to, you're going to have to make sure that you make that interior angle, whatever it is, 80 degrees, 90 degrees. But you're going to see 82 for most of our examples in this class. We start there, and remember, it was a 49-degree angle that gave us what we wanted. So I'm going to hit a tab, I'm going to change the angle to 49, it'll automatically set that at 49. On the other side, we believe it was 131, so I'm going to make sure I go past the top line, hit tab to change the angle to 131, perfect. Now I can trim. I'm going to draw this headline here, because we do see that, and then I can trim this section, and this section. And now I have a reference point that I can bring this up to my top view. And I could not finish this section because I didn't know where the outside of my counterbore was going to be. I'm just bringing up a couple of lines. These should really be construction lines, but I'm going to delete them anyway. So to bring that up there, and now I'm going to create a circle, because obviously it looks like a circle, from here to there. And then I can get rid of these two. I just used them so that I can make that widest part of the counterbore, so it'll line up with the widest part of the, of the countersink. It'll line up with the widest part of the countersink here. All right, I think my measurements are correct. I also note that I have a slot in here, and the best way to represent that is not to crosshatch that area. Otherwise, it might give us the indication that there's no slot there. So on my section view, I'm actually going to have a white line there, and I'm not going to hatch or section or color in that area to indicate that there is a gap there. I think that takes care of most of the features. Now would be a good time to turn off all my construction lines and just get rid of anything that I think I don't need. So this, I could have trimmed this, but I'll just drag it down to there, making sure I don't change the angle of it. Okay, so that feature looks fine. These features look fine. I will put the center lines in after. What I want to do now is I want to crosshatch the areas that are solid material. So that's going to be this section here, all of this around the countersink. Those need to be hatched. And this is the first time you've used the hatch tool. It's in the draw menu. You'll notice this is the hatch. And what are we going to hatch with? Typically section lines or some sort of diagonal. So let's select our hatch tool. Okay. And then we're going to do it in the same color as the object layer. Sometimes I have a hatch layer, but it's just as easy to do it as object layer. And your cursor should sort of automatically detect an enclosed area. So you can do multiple areas at a time. You see how it's just by clicking in the open space, it kind of knows what I want to do. And then when you're done, hit space and it will be crosshatched. So that's a terrible crosshatch. It confuses the drawing and it doesn't, that pattern is just not a good one. So let's change our crosshatch. We have to change our crosshatch style. So let's select our crosshatch. Remember, it's on our object layer right now, but I specifically have just the crosshatch selected. I don't have any of these lines selected. You got to be kind of careful about that, because when we go into our properties, we've got a hatch pattern, and it's called angle. Now, I don't want that one. It'd be nice if there were little. Thumbnail pictures of what each of these look like. You kind of got to do it by trial and error. And I'm just hoping there's one per section. And of course there isn't. So let's just try to find something that is a diagonal line. Not seeing anything called diagonal line either. Also inconvenient. So let's just see. What does steel look like? Oh, that's not bad at all. It's a dashed line. But steel's not bad because it is diagonal. So we could use that. Oh, let's cross. Where's my cross section there? That might be okay right there. Nope, that's actual crosses. Don't want those. Sorry, I should have checked this out ahead of time. Yeah, what else might be diagonals? If I can change the angle of those lines, it'll be perfect. And I can. 45. There we go. Now that's a real section. Our scale. That's not bad. You don't want it too cluttered, but you can sort of play around with it. I want it smaller than that. Maybe I'll do 0.5. There we go. Now that's looking good. So we've got diagonal lines. I just put in the regular line hatch style. If you remember, regular line. Change the angle from 0 to 45. Change the scale a little bit. Depending on the drawing size, you might have to manipulate that a little more. But that looks like a good cross section. It's very obvious what sections are hatched or filled. It's obvious what sections are counterbores, what sections are countersinks, and this right here indicates that there is a gap there. But the combination between these two drawings gives you a very good idea as to what this object is going to look like when you build the real thing. What else do we have to do here? And it's just the normal sort of cleanup. We're going to do some center lines. So I'll take my center line tool, my center line layer, and my line. Oop, a little bit of a crash here. Come on, web browser. There we go. All right, I need to get right in the center of this, and I don't have a center there, so I'm just going to draw it there, up to the top, and then grab it and drag it through the bottom. Something like that, and now I'm going to scale it appropriately so that I can see those dashed lines. I've got center times 2 in my layer. I might just make it center, see if that made a difference. Did not. Let's go a little deeper. Let's go into our properties. And let's scale this. I always forget if I've scaled down or up. I think line type center. There we go. Line type center, line scale 1 is good. That looks pretty good. Now, let's copy it. Instead of trying to replicate that, just copy it over. From here to the dead center there. Oh, forgot I didn't have a center on the top, so I'll copy that again. Except I'll do it from this center, because I know I have that center here as well. Okay, and I might as well just put this one up here too. And then just extend this one a little bit more because it's a little bit deeper. Down just a little bit so it looks a little closer to the other one. Okay, pretty happy with that. Now we've got to create our center marks. Let's get one center mark looking good, and we'll worry about the rest. Still checking to see if there is a center mark tool on this version of AutoCAD. It doesn't look like there is. No big deal, we can just draw one. We can draw one easily enough. All right, so we want our center line, our center mark to go outside a little bit, and Make the same changes I did before. Properties, line type scale 1, except instead of continuous, it should be a center line. Now it doesn't look like it's hatched right now. Center line, there we go. Perhaps I didn't have it. Oop. Selected when I did that. Nope, center, it's good. And when I make this line a little longer, it should hatch out. I could use the polar array tool for this to make it perfect. That should be good enough. Okay, so let's take this and let's do a copy. And I'll just copy it here. And then, why am I doing this? Because it's very easy for me to rotate it so it's the exact same size. I'll rotate this thing from the middle, and I'll just rotate it 90 degrees. Then it's very easy for me to grab it again and to move it with the M tool from the center to the center. I'm sure I have a perfect plus sign right in the middle. And we do. Now, copy to the other ones. CO, copy, center, the center, to the center. Oh, unfortunately, it was just a little bit too small, this one. So we are going to recreate this one. Make it a little bit longer. And then exact same thing we did before. Let's copy it. CO, space, from the center. Rotate it, R, O, rotate, grab it anywhere, rotate it 90 degrees, grab it again, M for move, should grab it from the middle, and put it on the middle. We should have perfect center marks. So center mark, center mark, center mark, center line, center line, center line, proper sectioning and hatching. Very happy with this. Scale, not great. The usual, select everything, layers, lock anything that is a drawing layer, center line, because I don't want to accidentally impact any of that. And let's change the scale of this object here being the title block, and let's make it about what we think it should be. I'm just eyeballing it. Something like that should fit. Reverse the process. Lock title block. Unlock. I usually just keep ortho locked. You only need it for your orthographic drawings anyway. And I shall see if this is appropriate. Yeah, that's not bad at all. So that would be a section view of the feed block. Save it up. And then you know how to submit it. As always, any questions, please let me know.